This conference will now be recorded.
Good evening, everyone. Thanks for taking time of your busy schedules and joining for this tech talk here today. I'm Raja Chandra Rangineni from Raleigh, North Carolina. I run this meetup group called Architecture and Emerging Tech. It's a technology meetup group here in Raleigh. I host interesting sessions, and one we have here today is from InsightFinder. We have Dan Turchin, the CEO of InsightFinder, who will be entertaining and educating us with their product from InsightFinder and how they are leveraging AI to solve one of the complex, interesting, and business problems, that is AI ops, using power of AI and how they're solving this anomaly at scale. That being said, a very quick intro about this high-level rundown about this Meetup group is I had a vision about this Meetup group in terms of here in Raleigh, and of course now it's virtual, it's across the globe, to create a platform to share the product, service, or an emerging technology that they have been working on, and showcase the products and solutions, share the vision and strategy around, let's say it could be anything enterprise that is across the board. The broader topics are broader, right, from, let's say, much of the historical topics on this particular meetup group have been on the AI, virtualization, more on the containerization, let's say DevOps side of things, have been on the business aspect as well, not just let's say tech, but is on the business, like business enterprise side of things, have been on the data side, big data, and so on and so forth. Again, the platform is for thought sharing and networking. That's exactly what we are here doing here today, and keep learning. That's a core motto. Some of the topics I encourage, and if any of you attendees are here interested for a future presentation, or you would like to share your thoughts, these are some of the areas: engineering, all the levels that you could think of, integration, cloud platform, any open source, commercial of the self solutions that you have, let's say, consumed and you have developed and you have you want to showcase. This is a perfect platform for that, and I encourage you folks to come to me. You're more than welcome, and to present your thoughts and products. Looking for a jobs. This is another connecting platform. If you are looking for a job, maybe Dan something. Finder, if you're practicing AI or some of these newer or even machine learning, maybe Dan, you have something you would like to share, or I'll take a quick moment. If someone has a question or looking for a job, please shout out. This is your opportunity. Also, I guess I'll take that as a no, but yeah, if you have anything for future, anything that you would like to connect, Dan, I hope you can share your, or Dan and Erin is from InsightFinder as well. You folks can share your LinkedIn profiles, and that's I appreciate that. Looking for future guest speakers and presentations as well, so you guys are welcome. That being said, the floor is open for you, Dan. Please take over.
Excellent. Thank you, Raja, and thank you to everyone for attending. Really looking forward to today's discussion. So glad you could join us. Let's do a quick AV check. I'm going to go ahead and share my slides. Let's confirm that we are able to see them. It's like you're seeing my my title slide. So again, welcome. I'm Dan Turchin, CEO of InsightFinder. I'm joined by Erin McMahon, who's also from InsightFinder. Erin is in RTP. I'm out in California. So for me, it's good afternoon. For all of you, it's, I guess, a good early evening. What we're going to talk about today, the principles of applying AI and machine learning to IT operations, is my life's passion. I've been in this space about 23 years, helped found or start 7 companies. And let me tell you, it's changed a lot. What we call AI has changed a lot, and what we call IT operations has changed a lot. And so we'll spend a little bit of time today taking a little bit of a tour through history, the history of IT monitoring, but we'll spend most of the time talking about what's unique about doing anomaly detection for machine data, to be able to apply those principles of AI, modern principles, technology that's bleeding edge to improving the health of your IT operations. So in terms of the three sections, we're going to kind of divide today's discussion into where we've been. And like I said, we've been a lot of places. Not always the right place, but certainly I've got a lot of stories to share about what it's been like to manage IT infrastructure in the past. We'll talk a little bit about where we are. Now, we didn't plan this, I guarantee, because of today's meetup, but just in the past 24 hours, we've seen a combination of Amazon, Gmail, and TikTok, horror of horrors, all experience downtime. So the role that we play as a community of IT ops practitioners is more important than ever. So many of the services that we rely on, whether it's to get our TikTok videos, or in my dad's case, his heart monitor is actually being reviewed by doctors remote over a digital service. So all these digital services are sometimes life critical, and the fact that we experience a lot of outages is a problem that is critical that we solve. And as a community, we're all working hard to solve it. We're also going to talk about where we're headed. So where we're headed is self-healing infrastructure. Where we're headed is being able to not just detect anomalies in machine data, but also figure out what they mean and what action we can take, so that ideally we can proactively remediate issues before any users are impacted. That's really the holy grail of applying AI to IT operations. So to help me get to know who you are, I'm going to ask you two polling questions, and it's also a nice way to get you out of being so complacent. You got to participate a little bit. I promise I'll do the rest of the talking, but take out a device, go to pollev.com/Dan Turchin 744, and I'm going to open up the first of two polls, and let's see who can figure this out. Oh, I can figure out how to go full screen.
Daniel, do you mind copying, putting that in the chat window so that everyone can grab it?
Yeah, Aaron, go ahead and do that. So two questions. So which of the following best describes your role? And the four answers, either A, I'm the head of IT operations, B, I'm a DevOps engineer, C, I'm a data scientist, or D, you just needed that 11 Zoom call today. Looks like at least one person figured out how to vote. You're going to go to pollev.com. You should see it in the screen as well. /Dan Turchin, number 744. And you're just going to pick A, B, C, or D. If you prefer text, SMS, that works as well. You can just text Dan Turchin 744 to the number 22333 with the letter A, B, C, or D. We got at least two people who figured out how to use the poll. Just give that another minute. Thank you for the feedback. Okay. Just give it a second before we close out that poll. So we've got a few lonely people and a few DevOps engineers. Thankfully, we have more DevOps engineers than we do have those who are lonely. Like you, this is, I believe, my 11th Zoom of the day, so I empathize if that's you. Good. Okay, I'm going to stop that poll and open up the second one. And activate that and share it. Okay, question number 2 of 2. Which of the following best describes your organization's level of AI maturity? A, it's super high. You are actively using AI for IT operations. B, pretty high. You're experimenting with AI solutions, maybe in other parts of the organization. C, we'll call it medium maturity. You're evaluating an AI strategy, maybe something you'll deploy this year. Or D, we'll call that low maturity. We still rub sticks together to make fire. Doesn't mean you can't accelerate if you're a D, but all right, at least 1 out of 5 is a D. We'll give everyone else a second to respond.
Just FYI, the chat's disabled.
Give it another 10 seconds or so.
Yeah, is it disabled?
Yes, it says the chat is disabled by organizer.
Aaron, if you could have a look into that, that'd be awesome. Thanks for that. Okay, I think that's the feedback that we needed. No one's quite at the level of super high, but presumably those of you that are in the high category, hopefully are here for all the right reasons. Exit out of the poll, and we'll go back to some slides. Thank you, that's helpful for me. I'll try to make sure I orient my comments appropriately. So, a little puzzle for you. So we're going to talk a lot about anomaly detection. And I'm going to go ahead and let you know that there's an anomaly in this slide. And my challenge to you is, can you find the anomaly? This is a lot harder than the polling questions, I realize. I'll give you another 10 seconds or so to stare at that. It took me a while the first time I saw this. And then the thing is, when you see it, you can never unsee it. It's like a Where's Waldo game.
It looks
Okay,
like
there is in fact an anomaly. I'll point out where it is. Give yourself a hearty pat on the back if you found it. So that's the anomaly. You'll notice that all of the other pumpkins have 4 swigglies in their mouth. This one, in fact, only has 3. Pretty subtle. Now, just to put this in the context of what we're going to discuss today, that's one pumpkin that's an anomaly in a few hundred pumpkins. Not an impossible task for the human eye. We're talking about finding anomalies at scale. So what we're going to be talking about today is anomalies in machine data. So time series data, logs, traces, things like that. And we may be talking about millions or tens of millions or hundreds of millions of, call them pumpkins or data points per day. And that's where it turns out the naked eye isn't so good at identifying anomalies. So we're going to spend some time talking about what is in fact the right way to identify anomalies in machine data. So first, a bit of context. So in terms of the adoption of AI technologies in broader disciplines, they're all but ubiquitous in ways that you might not even realize. So we've come a long way. AI is now relied upon to do things that permeate your work and your personal lives. AI has been trained very effectively to do image recognition, very effectively to recognize speech. We use Alexa and Siri. Very effectively, it's able to classify different components from data. It's able to make predictions, and it's able to detect anomalies in machine data. Now, in terms of what kinds of AI are most appropriate for which kinds of AI tasks, that's where there's less consistency. We're going to focus primarily on the bottom row today. But in terms of the kind of role that AI plays and will play increasingly in our daily lives, I think nobody said it better than one of our leaders, at least out here in Silicon Valley, someone we revere, Sundar Pichai, who's the CEO of Google. I guess the company formerly called Google, now called Alphabet. And he went on the record last year. He said, AI will have more impact on humanity than fire or electricity. It's a bold statement, but I think when you start to think about whether it's heart monitors that are being measured with AI, or Amazon's website, or all the kinds of services that we rely on, I think you'd agree that the impact that AI is having is pretty darn significant. So this conversation we're going to start today is an opportunity for you to really establish leadership within your organization. And if I leave you with nothing else, it's going to be hopefully a few actionable takeaways where you can go and be that lightning rod within your own organization to introduce some of these principles, but in the form of very actionable use cases. So I thought I'd begin by talking a little bit about how AI is used specifically in the life cycle of a digital service. So now we're moving on from kind of, your Netflix recommendations or your Facebook news feed, also using AI to things that are more kind of germane to our domain in IT operations. So first, AI can effectively be used to figure out where you need what capacity to drive what workloads. Easy for me to say. It can be used to figure out how to provision certain workloads. So we always have the choice. Do we want it to be in a private cloud? Do we want it to be in a hybrid public cloud? Should it just be in Azure? What services are better for Azure than AWS? These are data problems. And armed with the right data, you can answer those questions. So monitoring, that's what we're going to focus on a lot today, is taking in kind of monitoring telemetry from various types of systems across the application stack, including even networking gear, and figuring out what it all means, and then more importantly, what to do about it. But what to do about it is the incident management. So once anomalies have been detected, it's really important for that same kind of approach to AI to be able to figure out what to do about the anomalies so that you can, like I said earlier, prevent any kind of downtime before it impacts users. Lastly, remediation and knowledge management. You can take that action and feed that back into a learning model. So the next time, let's say, the same threshold is breached, or the same exception is thrown in some code, you can figure out that that's probably correlated with an incident that has occurred in the past, and use that learning to be able to automate the process of remediating a potential incident in the future. We've come a long way in the last 20 years. I think these two pictures sum it up. I'll share one colorful story. This was something that was relayed to me by a customer recently. She said, probably 15 years ago, their quote monitoring strategy, literally, you can't make this stuff up, was to send the interns into the basement with a pad and paper and literally record on a sheet of paper which lights were blinking and which lights weren't. And the servers that didn't have blinking lights, that meant they were down. And the remediation technique was to turn them back on. So thankfully, we've evolved as a monitoring community. We've gone through several generations of kind of heartbeat monitoring, which was in fact, I think, the predecessor to the interns in the basement. But everything from heartbeat monitoring to kind of heuristics or manual rules. We've done a lot of things based on the state that technology has been in. Thankfully, we're finally approaching an era where this holy grail of self-healing infrastructure may be close to possible, because we're closer to the right version of that screen, where we've got rich dashboards and we can automate the detection of anomalies. And then, like I'll share with you today, with the right kind of principles of AI and machine learning, we can take those anomalies and translate that into some kind of a framework for action. But thankfully, we have come a long way, and hopefully, those of us who have been along for the journey can appreciate that today's world of monitoring and anomaly detection and using AI and machine learning to fix problems is a much more mature way. Even though the problems might be similar, the way we remediate issues has come a long way. So a few statistics as we get deeper into kind of the meat of today's discussion. I mentioned that just in the last 24 hours, you've had a combination of Amazon, Gmail, and TikTok go down. So some of these statistics may not be so shocking. On average, as a Gartner estimate, 1 minute of downtime costs the average enterprise or digital service $5,600. I can tell you that for a service like Amazon, if you have an outage on the whole website, including payment processing, that's more like $240,000 a minute. So $5,600 is really quite conservative. 433,000 is the number of Google search results currently for cost of downtime. By contrast, if you've got kids or specifically daughters like me, you'll know that's a pretty big number, because that's close to an order of magnitude greater than the number of results for Taylor Swift, which I find hard to believe. But downtime, it turns out, is a hot topic. $1.1 trillion is the total annual spending on IT operations just by the Fortune 500, the 500 biggest companies in the US by market cap. That's a pretty big number, $1.1 trillion. Clearly, there is a white hot spotlight shined on being able to solve this problem to reduce the impact and the duration of downtime, but also the impact of downtime. 60% of CIOs who were recently surveyed by IBM said a lack of infrastructure readiness has delayed their business's growth. 40% of CIOs say they need to supplement humans with AI to be able to effectively scale IT operations. My question is, who are the other 60%? I mean, we looked at a couple hundred pumpkins, and that was hard enough. I don't know who thinks that they can do this across millions or billions of data points without the aid of any machine learning. So that kind of frames the discussion. Now, before we get into kind of some of the specifics about the right way to use AI and machine learning to detect anomalies in machine data, I thought I'd take us on a little bit of a history tour. I told you up front, we talk a little bit about the past, a little bit about the present, and a little bit about the future. Now, anomaly detection as a term is also often called outlier analysis for obvious reasons, and it's essentially the process of identifying items from a set of data that deviate from a normal pattern, kind of like 4 squigglies instead of 3. Based on that definition, it's clear that in order to detect what's anomalous, we need to first establish what's normal. So a lot of the kind of science of anomaly detection is finding out what's a normal pattern. As a term, anomaly detection has been used for quite some time. In 1986, a researcher named Dorothy Denning first coined the phrase. She was actually using statistical techniques for intrusion detection in the context of bank fraud. Common use of anomaly detection today as well. We've come a long way since then. We now use similar approaches to screen for tumors, manage crop yields, navigate minefields, and even address global warming. Now, broadly speaking, there are 3 ways to detect anomalies. There are visual methods, like looking at the list of pumpkins. There's statistical methods, and then of course there's machine learning based methods. Visual techniques rely on typically graphing data in 2 dimensions and just kind of seeing on that 2-dimensional graph what's anomalous. Statistical techniques involve setting rules or heuristics, some kind of thresholds. For example, anomalies might be points that are maybe a standard deviation above or below some fixed baseline. Well, machine learning is more appropriate for complex tasks like infrastructure management that involve algorithms that can identify what's normal on a rolling basis. In the real world, what's normal changes frequently, so machine learning approaches are increasingly being used to detect anomalies, specifically in machine data where the degree of fluctuation is high. Now, just within machine learning, anomalies can be detected using unsupervised, supervised, or semi-supervised techniques, where the latter uses labeled data to represent what's normal to predict the likelihood of new data falling within or outside of normal range. But today we're mostly going to explore kind of why in the real world detection for machine data is most appropriate for unsupervised machine learning. So you can see on this slide, I talk a little bit about how anomaly detection is used to improve IT operations. So it reduces false positive alerts. We're all too familiar with the noisy alert problem. So if you can figure out what's anomalous in a way that is actionable, then obviously you can kind of dampen the noise that would otherwise occur. It can help us understand what data from telemetry data has the most predictive power. It can help us move beyond that kind of point where we were at about a decade ago, where we're relying on heuristics or manual rules. It can certainly help us improve postmortems, because it can show us what the root cause of an issue was, so that the next time we can build on the learning that we did the previous time. And lastly, of course, we can take 1 through 4 and incorporate those into better decision-making processes that continuously improve, so that we can involve a fewer number of people to achieve greater benefits.
And a quick question.
Yeah.
When you have mentioned about the unsupervised learning, so what are some of the best algorithms in the unsupervised learning that have been you folks have used in terms of training your models that has, and what is the maturity curve that you have seen over the time period?
Yeah, great questions. That's a segue into, I'm actually going to do a demo in a bit, and I'll specifically talk about the attributes of the algorithms and some of our research. But good, yeah, if we just park that for 1 second. So I want to talk a little bit about what's different about detecting anomalous data when it comes to machines. And one of the big differences is that there's a high degree of fluctuation. So what's, quote, normal tends to be different, whether it's a weekday or a weekend, whether it's a holiday or not. Right after the launch of a new product, you might have just a crush or a surge in demand that might impact how the system operates. All of these patterns cause a high level of fluctuation. Not so much the case in a simpler time when the volumes of data were lower and the complexity of these architectures was different, but today that's something we need to take into account when we're designing how to use machine learning for machine data. Dimensionality, I'll talk a little bit more about this, but oftentimes because of the vast types of data and all of the different ways that data can be anomalous, we very rapidly run into this curse of dimensionality, and I'll talk a little bit about the way we address that, but it's important to acknowledge that certain algorithms, certain approaches were not designed to take into account that there's so many dimensions when we're looking at machine data, time series data, typically, metrics associated with CPUs and disk and storage and various kinds of interplays between those. We need to think about the number of dimensions as being able to grow without bound. Seasonality, I mentioned, your digital service is going to need to be monitored by a specific type of AI. And so to Raja's question about the best kinds of algorithms, I'll talk a little bit about how we determine that. To cut to the punchline, ensemble algorithms tend to perform the best, and that's what kind of takes into account some of this. And I'll show you specifically how algorithms at InsightFinder that we've tested compare to kind of simpler, more traditional techniques within the field of unsupervised machine learning. And lastly, volume. So at least at InsightFinder, we benchmark against hundreds of thousands of concurrent metrics being monitored, log data that can grow to 50 gigs plus per day. To be able to extract the kind of anomalous bits from that amount of data really requires some unique approaches. So those are all the reasons why monitoring modern applications requires a unique approach. What we'll talk about next is the way to achieve the most accurate anomaly detection, given that that's the environment that we're operating in. So kind of 10 principles when it comes to how to think about the right way to detect anomalous data, but also then to identify incidents proactively associated with those anomalies, and ultimately to be able to take some kind of proactive action by first identifying the root cause. That's a special set of problems. And so when we think about applying these principles to IT operations, we want to think about some of these items in this top 10 list of key principles. So self-organizing maps is the specific technology at InsightFinder that we use to eliminate that curse of dimensionality. The curse of dimensionality refers to very sparse amounts of data across a very high volume of dimensions. So we use SOMs, or self-organizing maps, to essentially reduce the complexity, to reduce the number of dimensions with sparse data. We use unsupervised machine learning. Now, I think it's pretty obvious to this crowd, but if you had to actually hand label sets of data to be able to train an AI algorithm, it would take an army of hundreds of millions of people continuously labeling data to be able to feed enough training data to a supervised approach. So it's really critical that the anomaly detection system is is predicated on unsupervised machine learning, so no labeled data required. In fact, at InsightFinder, our approach is we do online learning, so it's continuously ingesting data, establishing kind of a rolling baseline about what's normal, so that it can continuously flag anomalies without the need for any hand labeling of data. Multivariate anomaly detection, so this is important that not just different types of data, but across, let's say, metrics. So oftentimes it is the anomalous, let's say, CPU time series data interacting with, let's say, an exception thrown in a log file, interacting with, let's say, a rapid decrease in available memory. It's that combination of variables that often leads to the most accurate anomaly detection. So really important that all of these variables are taken into account when identifying the root cause of issues. High ingest rate is critical. You're going to make sure that you're sitting on top of a scale-out architecture that can both scale horizontally, but vertically as well. So different types of data, but also it can expand elastically. Short interval sampling, so you don't want to discard too much data. So it's really important that this data is changing fast. I mentioned it fluctuates at a high velocity. So in the past, we've seen sampling rates as little, as infrequent as 20 or 30 minutes. Well, you're just about guaranteed to miss the anomalies if you're discarding almost all of your data. So we look at, sub 5 minute or even sub 1 minute polling frequencies to be able to make sure you catch the anomaly right as it starts to appear in the data. Distributed processing, so you want to do as much of this work at the edge as possible. We rely on a combination of agent-based as well as agentless techniques, but it's really important that you deploy an architecture that's capable of distributing the load on the servers across worker nodes. It's very important that if you're ingesting logs, storing all that logs for reporting purposes or analytics purposes can be very expensive. So being able to not just store, but then compress those logs in a lossless way is really important. We achieve typically about 95% lossless log compression. InsightFinder is really a core part of our whole architecture. Being able to extend what's anomalous to why it matters is really critical. So being able to relate that to incidents, ideally with hours of advanced lead time, that's really what's ideal in IT ops, is being able to take those anomalies and then identify what they mean well before the incidents occur, and then being able to take those incidents and predict what's the root cause of the problem, so that within maybe that 5 to 7 hours that you have of lead time, you can go about fixing the problem before anyone is impacted. Really core component of applying AI to IT ops is that ability to do not just anomaly detection, but incident prediction and then root cause analysis as well. And lastly, you want a solution that's capable not just of kind of analyzing bits and bytes and logs, but also being able to feed those insights into better business decisions. So you want to understand what's the impact of this incident on my MTTR? How much downtime could I avoid? What's the cost savings to the business? So that when you're communicating out to the business why we're using AI to solve our operational problems, you have very specific business metrics that you can use to educate the business about why this is the right solution. So 5 key criteria to use when I saw there were no A's on the screen in terms of maturity, a handful of B's and some C's, even some D's. But to get from kind of C or D level maturity, or B or C or D level maturity up to A level maturity, these are 5 key criteria to think about when you're ready for an AI ops solution. So how accurate is it? Obviously, you want to make sure you're picking the right algorithms. And to Raja's question, we'll talk about that more in a minute. Does it scale to match the kind of volume that your systems generate? How usable is it? Is it something where a mere mortal can configure and manage the system? Ideally, we want this to be a way to consolidate a lot of different point solutions that are used in IT operations today. Incident management and problem management and topology mapping, and database monitoring, and APM, application performance management, and all of these different kind of point solutions, you really want AIOps to be able to consolidate a bunch of those point solutions into one kind of logical framework. You want to make sure it's extensible to other domains, but also to other types of data. And of course, you want to make sure it performs well. So high volumes of data should be able to be parsed and processed and learned from without having to kind of scale the size of your operations team. I'm happy to leave these slides with you all. So I realize it's a lot of text, but I do want you to have this framework for how to evaluate an AIOps solution. Hopefully this is something that's, you know, if it's not time critical or time relevant today, hopefully in the next few months you'll be ready for some of these topics. So now I mentioned kind of, we'll talk a little bit more about the algorithm. So I want to show you an example of kind of the output of our learning at InsightFinder. Our research team, specifically led by our CTO, Dr. Helen Gu, has published over 80 papers over a period of about 15 years about what the right way is to do this at scale. And so we want everyone, certainly in this meetup, but everyone in general, to be able to benefit from some of the things we've learned. So I was going to cut over and show you a comparison of the InsightFinder ensemble algorithm approach to detecting anomalies versus another very common unsupervised machine learning algorithm called DBScan, which is used at places like Netflix to do very complicated machine learning tasks, but not for machine data. Recommending movies in your feed turns out to be a very different problem than detecting anomalies in your machine data across your metrics and logs. So let me go ahead and go to a few images. So this is actually from the InsightFinder tool. In no way is this intended to be you know, a vendor pitch. I just want to give you a sense visually of when you look at kind of those 10 principles of applying AIOps to machine data, what the output looks like versus if you select the wrong algorithm. So this is using an algorithm that is part of our core IP at InsightFinder. And what it shows you is, this happens to be from a set of Cassandra data. We split a set of data into two, do cross-validation. Half of it went into training the algorithm and half of it went into testing to see how accurate the algorithm was. In this case, we see a rich pattern of anomalies up at the top. We see on the y-axis an anomaly degree. Something that's higher on the y-axis indicates it's more anomalous, and then we can hover over and see the nature of this, what nodes were impacted. We can come down here. This is actually all metric data. So memory and network receiving and sending and disk reading, et cetera. We can filter this by specific nodes. Let's see, what was that? That was on node, barely read that, looks like node 5. So I go ahead and look at node 5. I can zoom in on a particular period. This happened to be, I can zoom in on this if I want to. During that period, we saw this spike on node 5. So we can do the same thing and look at, what was the metric? So that was a memory, an anomaly related to memory. So here's our memory anomaly. Go ahead and zoom in on that one. Again, see where that particular pattern occurred. So we have a lot of diagnostic tools that we can use when the algorithm is appropriately detecting the anomalies. Now let's just say, hypothetically speaking, that you've picked the wrong algorithm. So you see an example here, read those filters. But if instead of using an InsightFinder algorithm, I instead use the same cross-validation approach, same data, same time period, and even the same metrics. So same raw data, but I instead use the wrong algorithm, what I see is completely broken. So this is actually using a DBScan algorithm, and in fact, this is using DBScan in a way that there were no parameters that were tuned. So with just some default parameters, this shows me that whereas InsightFinder saw, you know, a very rich pattern of anomalies in the data, this says actually everything's anomalous. It's just one continuous anomaly. So I scratch my head and I say, well, I don't think that's the truth. Let's go back to my clustering algorithm and let's say, I'm not an expert on the DB scan algorithm, but let's say I ratchet up my epsilon to 100. That's just a hyperparameter that I can tune. And then I rerun it, same algorithm, same cross-validation of training data, just with a different, in this case, parameter called epsilon. And now we have the inverse problem. In fact, now we've overtuned it and nothing's anomalous. So kind of frustrating versus something like an InsightFinder algorithm where without any tuning, you just get the right answer. So across metrics, in this case, logs, et cetera, from a Cassandra cluster, typical machine learning problem, typical machine data, very clear visually why the right approach makes all the difference. So if you just take away one thing, think about the actual importance of applying the right approach to be able to detect anomalies where you don't have, a continuous stream of false positives, but you also don't have a stream of false negatives, like in the examples I showed you with the DB scan algorithm.
I have a
I realize that's yeah, sorry, go ahead.
How do you know how to tune the hyperparameters? Or I guess, is it kind of trial and error? Or is there?
Yeah, so optimally, you shouldn't have to. So
Okay.
using the right unsupervised machine learning approach, you shouldn't have to know all the hyperparameters. In fact, with DB scan, we were showing there are more hyperparameters. With InsightFinder, it's going to auto detect the right way to tune the hyperparameters for optimal performance. Now, as needed, you have access to a lot of different levers and gauges in InsightFinder, but really the point it's making is you shouldn't have to be an expert in any one algorithm. The benefit of an ensemble approach to achieving kind of algorithmic efficiency, like what we showed in the InsightFinder example, the way to do it is that you shouldn't have to understand hyperparameters. Not intended to be a cop-out. I was just trying to illustrate that in the example that there are probably a dozen different popular algorithms out there. When you use an ensemble approach, then you don't have to worry about which specific one to select into.
Thank you.
Cool. So I told you at the top of this that I wanted to be able to leave you with some actionable takeaways. And one of my objectives is to make sure that you can go back and kind of spearhead your organization's AI Ops initiative. And that doesn't just mean, the top 5 criteria for selecting a platform. It also means being able to have the business conversation. So, something that we've all probably learned over the kind of arc of our careers is that technology projects tend to fail, business projects tend to succeed. And it's incumbent on us as leaders in IT operations to be able to understand how to frame these problems and how to frame the solutions in terms that matter to the business. So we think about this kind of as a pyramid. Starting with the base of the pyramid, establish some baselines. So collect some data about what's our current MTTR, how do we measure it, what's our goal, what should it be, what's our total cost to be able to deliver IT ops, are we meeting our SLAs, are we not? At the point where you've got some baselines established, set some goals. A logical one would be we want to reduce our mean time to detect. Maybe even before we can reduce our mean time to investigate, our MTTI, we first just want to be able to detect using anomaly detection, when something is out of whack. Then eventually, move up the pyramid to being able to reduce the time it takes to investigate. Ultimately, you want to reduce the time it takes to resolve the incident, to be able to reduce downtime. But it is a pyramid, and it's okay if kind of you mature in kind of somewhat like this order, where you're making incremental progress. But most important, you're able to essentially signpost to the business. We're at a level 5 right now. 6 months, we're going to be at a 4, then a 3, then a 2. And eventually, we'll be able to focus on that core KPI, reducing downtime. But before we can run, we're going to crawl, we're going to walk. And it's nice to have this kind of framework to be able to quantitatively identify to the business what the goals are of this AI Ops initiative. So at no point are you, asking for budget or resources, et cetera, related to what's purely an operational problem. You're looking at, what's going to deliver shareholder value, what's going to reduce the, customer churn, what's going to increase the, upsell opportunities. That's the language that the business speaks. And as you can see here, all of the language that we speak in IT Ops is really just, a very small conceptual leap away from the language that the business is used to hearing. So really think about how to translate your goals as an operations organization into goals that actually matter to the business. So as you might be able to tell, I'm kind of passionate about this stuff, and if you are, or if you're on the cusp of being passionate, I thought I'd share with you 3 good reads. Life 3.0 by Max Tegmark. He's a professor at MIT, but this is actually a fictional account of a somewhat dystopian view of the future, but it's a good read. Prediction Machines talk a lot about how to apply some of these technology principles to real world use cases. Good read. Ajay Agarwal from Bain Ventures is actually one of the co-authors of that. It's a good read. Machines That Think by Toby Walsh, another good read. Very accessible. These are not too academic. Good books you could pick off the shelf, and in a week you could knock them out and feel like you're a lot smarter for having read this. The other thing I can almost guarantee is you spend a little bit of time with these, and you'll get really excited about what making these investments in these technologies can mean for your career and also for your organizations. This is there's no better way really to future-proof your career in this space than to get kind of a good sense of not just where we've been, but where we are and where we're headed. And I think a little bit of reading can go a long way. I want to leave you with one of my favorite quotes. Maybe you've heard it before. Maybe it's a little bit of a cliche, but I strongly believe in it. What can be predicted is better left to machines, but now and even into the future, what requires judgment or empathy is better left to humans. I think you'll find from this discussion that AI Ops is not about eliminating the need for humans in operational roles. In fact, it's about making humans in operational roles the best versions of humans they can be. Like we saw at the top of the discussion, picking out the anomalous pumpkin, yeah, we can barely do that. We're not very good at it, but we can barely do it. But when it comes to being great at our jobs in the face of machine data, in the face of real world operational problems, the things that would have helped Amazon and TikTok and Gmail in the last 24 hours, it's not just throwing more bodies at the problem. To really become the best versions of ourselves, we need to embrace machine learning and really think about the future of intelligence as being this fusion of human and machine learning. So we would love to have you become part of the InsightFinder community. I think I made a point at the beginning of saying this is far from a vendor pitch. These are just some things that we've learned over the years that tend to be the right ways to achieve kind of level 1 maturity in terms of IT operations. They tend to involve machine learning, and they tend to involve unsupervised machine learning. So hopefully, if nothing else, I've shared with you just kind of a framework for how to think about some of the right questions to ask, but ultimately a framework for being able to go from this meetup and become a leader and be an agent of change and be the one who's educating maybe not just your team, but the whole organization about why the future is that fusion of humans and machines, and how maybe this gives you some of the right ways to start the dialogue and be perceived as a leader. That's the way that you're going to define personally, the next chapter in your career. But you're also going to bring a lot of others in your organization. You're going to help bootstrap their careers as well, and that's more important than any new technology. That's more important than any algorithm. So really, if you take nothing away from today, I hope you think a little differently about how you can kind of embrace the future of AI and machine learning to be the best version of yourself, and hopefully give something back to your organization that really helps you better compete in whatever field it is you're in. Now, I did want to make sure you saw that URL is for an offer for anyone that's watching this session today. You can get a free trial if you're interested in seeing AI ops done at scale. We offer a free trial. There's my contact info. I would love nothing more than to continue this dialogue offline with any of you. We're always happy to provide briefings of this kind of content. Again, not even a vendor pitch, but just kind of help you kind of mature the dialogue within your organizations. And with that said, I wanted to pause for breath. Feels like that was one long run-on sentence, but pause for breath and ask if you have any questions for me.
Sorry, I have a question. So I have very cursory experience with machine learning and data science. I finished my master's in it, but we really didn't touch heavily on the mathematics of it. I've been trying to get back into studying it a bit and trying to find ways to, I guess, implement it in my organization. But where I get tripped up on is specifically interpreting statistical notation and symbols, and I guess the mathematic equations behind the algorithms. Is that something that I need to focus on the forefront of, I guess, my journey into machine learning and data science, or is that something that I can kind of pick up as I apply these issues to real world problems, and it's not as important to know going in?
Good question. And I'm sorry, is that Lee?
Yes, Lee.
Okay. Hey, Lee. Thanks for asking. And are you a data scientist by trade, or what do you do for a living?
So in my job, I'm really more of, I would say, an analyst. I build analytical tools, reports. In some ways, we build, I guess you would say, like brute force algorithms to identify anomalies. But I would, again, ideally, I would like to try to expand the education that I had in data science into the AI realm of things and see if there's ways that I could incorporate that into the work that I do.
Yeah, Lee, so all of AI is founded upon some fairly common principles that go back to math and stats, but the whole AI ops approach is predicated on you not needing to understand the underlying math and stats to be able to achieve these kinds of benefits. So if you look at any of the modern AI ops platforms, including InsightFinder, you'll find that all of the math and stats and the equations that underlie the algorithms are abstracted from the operator. The idea is the operator is someone who has solid grounding in IT operations. So things more like networking and application performance and systems management. But if at any time you're working with an AI ops platform that expects you to understand Bayesian inference or how an algorithm is working, then you're probably not using the right AI ops platform. But if you pick the right platform, you're well abstracted from the need to really understand how the math works.
Okay.
Dan, another quick question from a use case perspective. Within your let's say enterprise use cases that you have used or propositioned InsightFinder, was there any in the area that you have solved with respect to cybersecurity or SIEM kind of use cases?
Yeah. So SIEM, for those who haven't been in the space, security incident and event management. So basically applying the principles of IT operations to security analytics. And in fact, that's an adjacent use case. We work with a lot of large banks where there's actually almost a seamless overlap between what's an IT issue and what's a security issue. For example, if a hacker is trying to get into a database, they might do it by throttling the number of API calls. And so what was a security issue, there's someone with the janitor's credentials who's all of a sudden trying to get root access to the database. Well,
Right.
it's a security issue, but it just became an IT issue.
Right.
And so oftentimes the kinds of data that's being ingested is a combination of, things that might traditionally be thought of as the security realm, but quickly combined with metrics like, CPU and storage and, bandwidth and that sort of thing that are pretty squarely on the IT realm. So they bleed into each other pretty quickly.
So that probably that also brings DDoS into the picture. And were you able to do any predictions of that before it has, let's say, yeah, go ahead, sorry.
No problem. In fact, we just published a case study that maybe Aaron can share with the group if it's of interest, about how InsightFinder was used to detect and prevent a DDoS attack. Specifically using all the approaches, all the technologies I talked about just now, but where it was actually in an attempt to bring down a server from a bad actor, and InsightFinder was able to detect that pattern based on looking at machine data, telemetry data from the application server, and so so just consistent with everything we've been talking about, it's a good approach for being able to do early detection of DDoS attempts.
Awesome, very interesting. Any more questions? All right, Dan, looks like no more questions here. So thanks for your time here today. Thanks, Erin, and folks from the rest of folks from InsightFinder. But especially thanks, Dan, for sharing your wisdom. I really appreciate that because often there are very few leaders out there who really share that wisdom, push all the like-minded to venture into the new unfounded areas, and certainly AI is one space. In the next decade, we'll definitely see a leap and bound change here. So I guess the early birds would get the prey there. So, but thanks for sharing the wisdom and a critical, let's say, the idea and the theory and approach behind InsightFinder, some of the use cases that you have shared here today. So it is really an awesome presentation. I personally have learned quite a bit from here today, and I hope the rest of the audience have learned and they start their AI journey as well. So that being said, thank you, Dan. Thanks you, Erin, and thanks to the rest of the folks. Have a good day.
My pleasure. Thank you, Raja, and thanks to everyone for joining. Hopefully, we'll be speaking in the near future.
All right. Thank you, guys. Take care.
Thank you.